It's important to have a decent set of tools. Without them, I think it's almost impossible to build one of these successfully. So I've got a soldering iron station. It's a cheap Chinese clone of a famous brand. On it I've got a small tip. It's a cloves foot one. And this works quite well for fixing up any problems on the small components on the board. I've got a reasonably decent set of cutters, a fine set of pliers which are pretty useful, solder paste, some proper flux. Don't get cheap stuff, get some decent stuff. This is no clean, but we'll still clean it later. But you want to get something decent. This is a Kingbo brand one. I usually like to put it in a board holder like this. You don't have to, but it just means that I can, if I'm moving stuff around on there, it's not going to move the board around while I'm doing it. So I use a needle. You could use a toothpick as well, but I use just a small needle, and I use that to put the solder paste on and also to clean things up on there and move stuff around. Make sure you get a decent set of tweezers as well. Don't go and get some from the chemist. Get a proper set of ones. These have got a really fine point on it, so they're good for playing with those little components. And there's some pretty tiny ones in there. Those 603s starting to get down pretty small. What I do is I've got a white container here that I've chopped off, and I put all of the components in here first. So when I put down a resistor, I'll put that resistor in there first so I don't lose it, and then check my placing with a schematic and then put them in here. I also use one of these. This is a Optivisor. Don't buy the cheap, crappy ones from eBay. Buy something decent. These have got a glass lens. I think these are a 2 magnification. You'll want something like that so you don't strain your eyes. And the other thing I think's pretty important is a microscope. If you're going to do a few of them, to be able to see problems on the circuit board, you're almost flying blind without one. So this one's just a cheap Chinese one. It was about $140 Australian. It's 20 times and 40 times, and it works quite well. I can get this soldering iron under here with the PC board on there and clean up stuff if I need to. But that's really handy for. You could use a jeweler's loop, but I don't know how well that would work. You can't get a soldering iron under that one, but this one you can. You can use a soldering iron and see exactly what's going on here. So what we're going to do is, basically what I'm going to do is, on here I'm going to put down some solder paste into a piece of paper, and then I'm just going to put these on bit by bit. So just grab a little dab of solder paste and just go like this, putting it on. And I'll do the whole board first, and then after that I'll start placing the components. Normally you would have a mask which you put the solder paste on a lot easier, but unfortunately I don't. So what I'm going to do is just do it by hand. It takes a while. However, you can get a pretty good result with this, a really nice result at the end. So I'll do that, and then we'll come back and have a look at what's next. Okay, what I've done is I've gone through and put using the needle, I've just gone through and just put solder paste on each one of these. You can see here on these finer pitches here on this IC that we're going to put down, I've just put sort of a line across there and made it quite light, not too much there. You need very little, and covered these. The other ones I've just put a dab on each one. So what I'll do is, now I'll go through and place each one of these components here. And I usually like to work from the top of the board. and work my way down, placing components as I go. And then each time I put a component down, I double check and then I triple check. And I have the schematic open in Eagle on my computer, and I just check those as I go and make sure everything is exactly as I put it on. There's no second chances usually with building one of these, and a lot of those smaller 603 components don't have any numbers on them, so you have to be as good as a machine when you're putting this together, otherwise it's just not going to work. And troubleshooting it, that's going to be very problematic. So put the solder paste on. Now I'm going to place these components, and then we'll come back again and have a look what I've done. Okay, I've finished putting the components on. I've really taken my time here and double checked against the schematic. I'm just checking one more time actually. Okay, you can see here I start off basically putting the I usually put all the resistors and capacitors on first, and then put the bigger stuff on last. Otherwise, sometimes you have a tough time to access. So if I come down here to the microprocessor, when I've put that on, it looks a bit kludgy at the moment, but it'll come up really nice. And you can see the same thing here. It looks like that'll end up with a whole bunch of solder bridges, but what it does is when you we're going to put it on the pan. When you do that, it heats up and the solder automatically goes to the pads. We'll just come down here and have a look at the rest. The rest of it's pretty easy to do. You can see it's not super neat, but in the end you'll see how nicely it all turns out. So, with the microprocessor, make sure they're absolutely lined up, those pins. Otherwise you won't get a second chance there. It'll be a real pain to fix it. So I'll just turn this on. I turn it on to full heat. I'll just zoom in so we can see what happens. And basically we'll just wait. You'll see it start to work in a minute. Doesn't take too long. Okay, what I've done is I've turned the hot plate off. I let it cool on the hot plate, and once it's cool, I take it off, and then I chuck it under a microscope and check, usually starting at the top and work my way down. And I check every component and make sure that they're soldered on correctly and there's no bridges or anything funny going on. You can see it gives quite a nice result. Here on the processor, I had 3 solder bridges. The way to get those off is to put a tiny bit of flux on them. I usually put the flux on a needle and then put it on the solder bridge on the on the processor, and then I get the soldering iron and I just touch against it and it'll suck it off. So I had 3 on there. If you look at that under a microscope, it actually looks quite nice. Everything else came up really good. The digital analog converter there is fine. So okay, so the important thing to do is we're going to make sure that this chip can be programmed before we put anything else on. As soon as you put on any of these larger, taller components here, it's very, very difficult to fix anything up if there's something wrong here. So what I'm going to do is I'm going to solder on this JTAG connector here, and I'm going to solder on the power. Once those are on, I'm going to program it. If it programs successfully, then I'll put the rest of it on and see whether it all works then. Okay, the last thing we want to do before we plug this in is just check. We want to check between the negative volts and the positive volt rails that there's not a short there. So I'm just going to put my measure from the ground to my negative, and you can see if I got 0 here, that means it's got a short there and I've stuffed something up. I'm going to do the same thing on the other side as well. So there's quite a high resistance there, so looks like I should be fine. Okay, now we're going to look at programming the board. So I've got an actual ST-Link V2. My life's too short to try and use all junky programmers, so I've got a proper one. I think it's about $50. You need this adapter thing as well. Changes it to this small one which fits on the thing. So basically what I do is I plug this into the board. It needs to be powered. I've got a little test power supply here. Here's the board. So I'll plug it in. Hopefully nothing blows up. It looks okay. I use the proper utility, the ST-Link utility from ST Microelectronics. It's just my personal preference, but I like to be able to see exactly what's going on here. So the first thing you do is you hit connect, and it's connected straight away. So my choice for this was correct. If you put it in the wrong way, you just flip it around. If it doesn't connect after you reverse the connection, it means somewhere on that board you've stuffed things up, you've put the microcontroller around the wrong way, or the pins aren't done correctly. So just have a look here. So in the settings, if you're using the JTAG, which I am, you got to make sure you change it from this when you first install it to this one here, which is a JTAG one. Apart from that, you just leave everything else as is. Target, I just go to program. Now, I'm going to choose the bootloader first. Press open, hit start, and it's programmed the bootloader. And then I just need to put in the actual program as well. So program again, browse, and I'm going to choose the hex file for it with the actual Peaks program. Hit start. So I can see exactly what's going on here. I can check the memory afterwards if I need to. And if you have a look here, you can see that it's programmed correctly here as well while you're doing it. Okay, that's done. Right, so the last thing we need to do is just solder in all these pots and the LEDs, switches, all the jacks. One thing is these alpha pots have got these little metal tabs on there. I like to pull them off, so I get a pair of pliers and just move it backwards and forwards until that snaps off. So you get something like this here. Because sometimes when you see that, they'll run the traces under that board where those tabs are, and I'm always worried that it'll scratch through there and short that and blow up your module. So yeah, I grab these and just snap these off. So basically you stick the rest of these in. Once you've got that, I put this on. Put all of the things on, tighten it up, otherwise you'll put it together and it'll be out of alignment. And it won't look that good, so. You want to do all of them, especially these, otherwise they'll look a bit funny. This sort of pulls it all into alignment. And you can move things around before you solder it. So just do all these up finger tight. Move it around so you're happy with how it looks. Like this for the LEDs. Flip it upside down before you solder it and then solder them all in like this. And then it's basically done. So what I've done is I've put the knobs on, finished soldering the back, and it's just ready to test now. So I'll plug this in. And looks like it's working. So I'll just fire up this. You don't really need an oscilloscope to do this, but it's handy to check actually what's going on with this. So it looks like it's working. So yep, that looks fine. I can try the trigger as well just to test that's working. Okay, that looks good as well. So I guess I'd like to thank Oliver from Mutable Instruments for making these available, as I've learned a hell of a lot building these. Just looking through the circuit diagrams and figuring everything out. I couldn't have imagined building something like this a couple of months ago. Oh, there's a drum as well, so that looks good as well. But yeah, it's been a very good learning experience. And if you take your time, it's definitely doable to make something like this. But there's a little bit of technique involved. So